Good morning, class. Welcome to a new era of surface area, an era of area. Look on your screen right now, open up the assignment. You should see number 1 looking a lot like this, where it has a cube, and you have different numbers than me probably. I have 19. You should have a different number than 19 most likely, but they're all 3 going to be 19. As you open that up, let me give you a little reminder about what surface area is. A few lessons ago, I talked about the difference between volume and surface area. If I had to deliver a package right now, say I had some super rare toilet paper, and I was going to put it in a box and ship it across the country to a place that didn't have it, how much toilet paper I could fit inside the box is an example of volume. But I also wanted to gift wrap it because this is an incredibly generous surprise. I'm sharing some of my rare toilet paper with somebody across the country. How much wrapping paper I could fit on the outside of that box is an example of surface area. All right. To find surface area, there are a lot of different formulas, but honestly, what we're going to use is we're just going to find the area of each individual side all around our object, and then we're just going to add them together. Or, in the extremely rare cases like number 1, since every single side is going to be the same, they're all 19 by 19 squares. This is the only example where I can easily, and they're not all going to be this easy, but you could take your side length, again, mine's 19, you could multiply it times itself, and then you can multiply it by how many sides you have, and a cube has 6. So for your number 1, simply multiply your side length times itself times 6. Because you're multiplying it by itself, you can also do it squared times 6. Either way, you'll get the same answer. If they're always that easy, this lesson would be faster, but instead, they're not. Like for instance, number 2, I have a much more regular rectangular prism here, in that each side is not the same. It's an 11 by 5 by 20. So I'm going to clear this on the right so you don't get confused by that wonderful square prism example. Instead, here's what we're going to do. You're going to take your 3 sides and you're going to figure out each combination of numbers. So I'm going to take 2 of them. Like I'm going to take 20 and 5, multiply them together. 20 times 5. Now, you'll notice 20 times 5 is this right side. Well, it's also 20 times 5 over here on the left. So I need to do times 2. Then you could add that with 2 other sides. So I'll do 11 and 5 because the front and back are each 11 by 5 times 2. And finally, that leaves 20 times 11 times 2. You can also do this. I'll show you a few different ways. You could do the 20 times 11 plus 20 times 5 plus 5 times 11. And then at the end, you could put the whole thing in parentheses and just multiply it times 2. It's a little annoying. I get it. It's tedious. It's so much you can't even see it fitting on the same box. Can I make this a little larger for you? Yeah, there you go. So maybe I'll do that for this one. Yeah. Okay. Because you need to include every single side. And because they're opposites and they're the same, you're going to be multiplying by 2, either at the end or individually. The same thing for number 3. So I'm going to take 5 times 4 times 2 plus 31 times 4 times 2 plus, 31 times 5 times 2. It is a little tedious, but once you get the pattern, at least for these rectangular prisms, it's the same thing each time, and that's kind of nice. And we're halfway done. I only gave you 6 of these because I know it's a little bit complicated computation. All right, number 4. We now have, for the first time, an object that is not a square or a rectangle. In this case, we have 2 triangles in the front and back. For these, we're going to have to add in the area of a triangle plus our rectangles. So how many rectangles do we have first? We have these 19 by 10 rectangles. 1, 2, and then a third one on bottom. And they're each going to be 19 by 10. So I can do 19 times 10, or 10 times 19, your call, times the 3 we have. But then I need to add my 2 triangles. So you'll notice there are 2 triangles, and because triangles are base times height divided by 2, to account for both of them, I could do 10 times this red height of 8.66 divided by 2 times 2, or to save the step of the canceling of the dividing by 2 and times 2, you can just do whatever your height is times the bottom. And that's it. So, to recap, and you could pause after this to get it as many times as you need. You do your 3 rectangles, length times width times each other, plus the base of the triangle times the height of the triangle. And that's it. All right, 5 and 6. They give us the base area, which is 139. Each of these prisms have 2 bases. That's what makes them a prism. So I can do my base area, whatever you get for that, times 2 to account for the bases. Plus, I need to figure out how many of my rectangles do I have on the outsides. My rectangles are going to be 9 by 18, so whatever 2 numbers you have down here for your rectangles, so 9 times 18, times how many rectangles I have. Well, that matches the number of sides in the base. 1, 2, 3, 4, 5. A pentagonal base. And when you do that, it gets, for me, 1088. So grateful they gave us that base area, because if not, we would have to use complex trigonometry to find it, and that is above our pay grade right now. All right, this one's almost exactly the same thing. Our base area now is 166 times 2, except, check it out, you have a different base shape. We had a pentagon before, now we have 1, 2, 3, 4, 5, 6-sided hexagon. So I'm going to do 12 times 8, not 9, times how many sides I have? 6. So you'll notice I did times 5 up there because I had a pentagon. Now I do times 6, and I get 908. So you do your base area times 2, plus your length and width of your outside rectangles times 6. When you get this right, you will hopefully have all 6 problems done correctly. You can submit it. When you do, you will see that you get 100%. This took me a little bit longer than I was hoping, but you know what? That computation, just explaining it on Desmos, takes a little longer. All right, that is our first of 2 lessons on surface area. When we come back next time, we will do surface area of pyramids. As always, this has been class away from class, and I hope that you're all safe, happy, well, and that you're just enjoying life as much as you can away from school. Much love to you all. Take care and have a great day.